Okay, good morning, everybody. Welcome back to my seventh Leetcode stream. Let's continue. Hmm, let's continue with the greedy problems again. Should I try combinatorics? Maybe try hmm, strongly connected components. Maximal 4 directionally. We are allowed to change any single land into water cell. Minimum number of days to disconnect the grid. Okay. Minimum number of cell to disconnect the grid. These are connected together. So I want everyone to have like a, so it is like a connected component of size 4. So already solved it. Is this all about finding articulation point? Yeah. Um, Hello Shubham Bhaiya. Hi Rohit. Screen is not visible, my bad. Sorry. I was discussing this problem. So we have some ones and these are forming a whole component. So this is like forming a component of size 4 and we want to break the component. So we just have to find how many articulation points we have. Now articulation point is a node basically which connects two components together. So if we will remove it, then your whole component is going to break. I already solved it in December. You have dragged. No. Okay. This is like the code. So this code is for back edge. Should be storing back edges too. No. I could also find bridges. मैं थर्ड ईयर में हूँ अनीश. I need to see this actually. I believe I have templates. Back edges is a easy concept. Bridges, bridges. It is like a edge, and articulation points are going to be nodes. Hmm. Office time. Bye bye. Bye bye. So I'm adding it as visited so that I can store like back edges. Maybe if it is already visited, then we got a back edge. I'm going to store whatever is minimum level. Okay. Can I simply do DFS? Same thing. If it's not, then is the bridge condition. If child is greater than, then we have this articulation point. If this is true, then we are going to push. Should I do problem of the day? What's your tech stack? My tech stack is I use Next.js. Um, I mean, I know Mern stack, but I don't use Mongo that much. So I prefer using like SQL. Although I have a project, I have used NoSQL database. I mean MongoDB, but I'm actually working on this new project and I'm kind of using SQL database. I know React. I know Express, but I use now I'm using Next.js because of its routing and all the optimized things. Maximum non-negative product. Non-negative. Initially, you are located at the top left. Each step you can only move right, down. Okay, so I can only move right or down. Possible path starting from top left corner, ending at the bottom right. Find the path with the maximum non-negative product. The product of a path is a product. Maximum non-negative product. Maximum non-negative product modulo. If it is negative, then return -1. So this is -1 because everything is negative. Modulo is performed after getting the maximum product. Till 15. So we are not limited by constraints. Okay. So 15 into 15. It's okay. It's about like 200 something. So what we want? Maximum non-negative. Okay. So what is the goal here? The goal is to maximize product. Okay. Right. Now if it's coming out to be negative, right? If it's coming out to be negative, then we can just return -1. Okay. Now, how are we going to do this? Okay. So 1 2 3 4 5 1 2 3 1 2 3 4 5. Okay. So if my current product is some negative number, okay, so I'm not limited by constraints. So I can brute force. I can do like n square. Um, so so I can use a queue. If I'm at some grid, for example over here, and the product is maximum, is it like the best possible condition? This is what I have to think about. No, if this is negative, then we are going to get a negative answer. But we want positive only. Okay, so basically science doesn't change the magnitude. Okay, so magnitude is going to be same, right? Only signs will change. The first thing. Let's just do it. What I'm gonna do, I'm gonna check for every single grade. Yeah. Let's define a check. Now I'm going to take two numbers I and j, and I will check whether they are valid or not. So if and j is greater than equals to 0 and j is less than m, then I can return true. I'm just going to use q here. Yep. What do I need? I need three things in this queue. So I can make it a tuple. Okay. This is going to work, right? Yeah. Let's also track the answer. I'm taking this the module is performed after getting the product, right? So I'm just taking it as long. I hope the syntax is fine. So if this is not empty, then let's extract the values. So we have I, we have j, and then we have let's say I'm defining it as cost. If front, then I can do q.pop. Is q.pop is fine, or do I have to do like pop front? I don't know. If I equals to n minus 1 and j equals to m minus 1, but we can like stuck in a loop. So so like this can check for this, then you can go here, then you can go here, then you can go. So we need some kind of a pruning here, right? Maybe I only have to visit some particular index only once, and not like once I have visited this one, I don't have to go here again, right? Okay, I can't even go there, so there is no loop, so this is going to be fine. So in that case, answer is going to be the max of answer comma c. C is my total cost. Let's push this q. We don't stuck in loop, we are we only going at 0 0, and we also have this thing here. Now I want to go like in two directions, so I can just do create array of size 2 comma 2. So we have two directions. So row is going to be same, and we are going to the next column, and we are going to the next row, and the column is same, right? Let's call them dx and dby in these directions. Let's say row is I plus dx, and column is j plus d by. Let's verify them. So if, what is it, check, if check of r comma c, if this is false, then we can just continue, we don't have to do anything else. What we do, we push the value inside. So what we push r comma c comma, oh c is going to it cost, and we also need cost into whatever is at this position RNC. Okay. um let's see what we have. We will take modulo towards, we have compiler error because n cannot be implicitly captured. Do I need to do like now? Okay, now it's good. I can't call max because cost is not like long. Now it's fine. We got wrong. Okay, we got the answer by the way. So we have this answer. Now, if answer is less than 0, then we can simply return -1. Else, we can simply return answer mod. Let's define this mod. Constant mod is 1e9 plus 7. We just do this mod. Okay, and I think it's done. Yeah, we got TLE. Okay, I'm wondering now, I'm thinking like maybe we should go for a priority queue because we only want the max, right? I want this to be maximum. Let's wait, can I do something? Why I got TLE? Shouldn't be. Am I getting stuck somewhere? This is fine. Okay, and check it's two adjacent node only. What is the time complexity of this queue code? By the way guys, we can do this using DP as well, so that is also possible. We can go to this and this, something like that. Let's go with the priority queue. This is going to give the right solution. Okay, have cost here, we want to maximize it, right? So if cost is less than 0, then -1, else return cost. Q.top. We don't have push. Wait. We have a tuple. What's going on? No match. No member matching function call push. Priority. Priority queue, right? Dot push. Priority queue. Is my name correct? I think so. Long int. This is also correct. Okay. What's the issue? Oh, why am I stuck? My network is fine. Is Leetcode down? I guess. No. Oh, this is the error. Okay. Syntax mistake. No, I'm getting wrong answer. What should I do? Should I just use dynamic programming? I can memorize INJ and I can, yeah, pretty much it. But um, what's the issue with this code? This will return me 0. So this is why I was not using priority queue before as well. Let's do this with the other way. Um, can be long. I will be having I and J, and I will be having do I need to track something else? Maybe not. So my base condition is if I equals to n minus 1 and j equals to m minus 1, then I can simply return whatever is at that position, right? J. Okay. If I have something else, if this is not valid, I can also check here. Wait, if it's not valid, then this is a wrong path. So what is the this can make things worst. Zero is also possible. If there is any zero in a path, even a single zero, then zero is always possible. So I should remember that too. Yeah. Um. Well, now I should find some path. Hmm. What I'm trying to do here. Let's do a -1. Fuck it. Else we return this grid. How do I deal with this? Hmm. If it returns 0 and there is no 0 in a path, that means it's going to be -1. Okay. Let's see what I'm getting from this. And I only care about maximum till now. I don't think that is correct. Why my priority queue solution failed? I got 0 for this. There is a way to go there. Maximum shit. Again, we got 0, but 8 was possible. I can go this path. This will make it -2. This will make it 3. So I'm assuming. What if I just go for maximum? Okay. I will try to maximize the magnitude, and I will track down how many negative numbers I have in the path. Right. Or maybe I can do like odd and even, whether there are even negative numbers or odd negative numbers, kind of flipping. So I don't have to worry about negative numbers anymore. Right. And I will maximize in both conditions. Maybe when they might be odd, they might be even. And that way, we try this thing out. Let's use a boolean to check whether it is negative or not. Okay. Here, I will do something. Okay. Let's do rid of ij is less than 0. If this is, then this is going to be not of this negative, whatever it is, else equal to negative, and I can push this value down. This is the only thing I care about. Bro, tell you every day do DSA question because I can't do in consistent manner. Huh? Oh, how I do it every day? I don't know. I have nothing else to do, so I just do this. I think this is the best possible explanation I can give you. This one seems pretty correct to me. Let's see what we have. Now, okay, so अगर negative है then true, false. We have 36. First value is negative, then maximum is 36. That is, I can check on DP. It's okay. This is coming out to be 16. Can I get 16 here? 4 to 8. Excuse me. What? Need to think. Can I even have 16? V is the current value. I and J. Multiplying this, and I'm calling the next value either this or either this. So, oh, I am going this path. 2, then 4, 2 ja 8, 2 ja 16. But what is the problem? Because this is going to be negative. And what is the longest for positive? We have 15. So let's make it 16, 16. 2, and let's assign. You are making every element positive, then you are multiplying. Yeah, I'm checking for maximum magnitude only. Let me see. This might be incorrect. Let's do a mem set. What I'm going to put here. Of ij comma negative is not equal to -1, then simply return. Now I can size of calling this. Now I will see what is p n minus 1, m minus 1, and negative is false. We have -1 in second. That means it's not possible. It's not possible to have a positive one. That's bullshit. I'm getting -1. Do I even need this case? That is why. I'll get 0 when I go here. But the check will fail anyway, so what I'm even trying to do? Let's be a little bit cleaner. -1 because it's not possible. Then we have 0. 0 is the maximum. Is there any mistakes or what? I'm just wasting my time too much. Fuck. If this is negative, then true, else false. What about 0? 0 is not negative. Okay. I might be getting 0 because no, well, this is already false. So if I go this way, this is not going to work. 4 to 8. It should be 8. Right? My code is correct. I'm checking for the previous I have it for like the current index that I have, and I'm doing the same shit here too. So what the fuck? Fuck this. What is this problem? My logic seems fine to me. Like, actually, this is less than zeros, then not of negative. My answer can't be negative because when I will reach this particular index I and j, these are going to be false, and then I will be storing 0 here. That is not correct. Can I fix that? My base case is my base case is not good. So if I'm here, this is my answer. If I go here, then I multiply this by whatever is the answer I'm going to get back. Okay. Now we have some overflow issues. This is my current absolute value. Okay. I have this value already. My brain stopped working now. Okay. Currently negative is false. Still false. Negative is true. Negative is false. Still negative is false. So I should have something like 8. Why do I have some? This is not correct, I guess. Um, should I print? I think I'm doing something wrong here, like, but I just can't see it. I can see like what's my answer. Some I comma j and let's see this for this specific example. Okay, it's 8. At 2 comma 2 it's just 1. I wonder why is that happening. Okay, that is absolutely fine. When I'm at 0 comma 0, this is coming out to be 16 because I'm multiplying these three. But then my negative is what? So I should get it if negative is true. Negative is false and it is 16. Something is wrong with my code. I'm at 2 comma 2. Negative is true here. Right? Because this is why. 1 comma 2. I don't know. I'm getting 16 for no reason. Oh, but like, wait. But here value can be both. Let me try with both. $16. Okay. Uh, fuck. ij whether till this path something is negative or not negative. And I will start at either a negative number or a positive number. I'm only doing it for only care about absolute values for now. I just want to maximize these absolute values. This is just a DP check. If not -1, just return. Then I'm initializing my answer. So my answer is what? Um, am I stupid like a bit or something? Because I'm finding answer in like a bottom up approach. So going from here to here to here. I was looking at n-1, m-1. Wow. Okay, that's crazy. Now we have the. That means there is a way to go somewhere. Maybe not. Let me try. Uh, I don't know. Just ask GPT at this point. This is incorrect for product problems. Both matter. Wrong initial call and wrong return, so everything is fucked up. Magnitude plus sign. do something else. So given integer array nums, the value of this array is defined as the sum of their mod of their difference. You are allowed to select any subarray of the given array and reverse it. You can perform this operation only once. Maximum possible value of the final array. What will... Okay, so is this thing... See what? No, I will do this like afterwards. I'll solve some other problems for now. Maybe my brain cells are not active to solve this problem. I can solve something else. So I can reverse some array, and reversing, what is reversing going to affect me? So currently let's take this as an example, and I want to maximize. So currently it's going to be 1, 1, 2, 4, 1. So 8. I want to maximize it. If I will reverse this, all the values inside this are not going to change. The only thing is going to change are these two indices, right? So this is going to match with this one now. So apart from having 1, you are going to have 3, 8, and this is going to match with this one. So this is still 1. So you got 10, right? Okay. Can only do it once. And if I will reverse the whole array, nothing matters. Okay, everything is going to be same. I can try to... So maybe reversing this may help us. If we have 2 pointers, then this pointer is going to check with the first one, this pointer is going to check with the second one. If we have better answer, then we will make a swap. Okay. It's all about how much I can increase, how much I can increment. And I will check till until j is greater than I. But there might be a situation, something like this. Then what? Guaranteed to fit in integer value. Hmm. So the difference between this and this and this and this. What is the total difference? 3 and 1 4, and what it was before 1 and 2. This is why this particular swap is actually better. But how will I check under time constraint? There can be any subarray, right? Um, I need to check it in one go. But everything inside it is going to be same. I can perform this operation only once. I should have like some condition that if for some index I and j I can make a swap, then I can optimally move whether I can do like I plus plus or j minus minus. I need something like that. I can't check for all subarrays. What is the best option for 3? So currently my difference is 2. Difference is going to be 2. It's not optimal to do this. Swap. Because for 3 this is going to increase. So you need some value that is at some bigger delta. So for this 2, difference is 2. If I could do like 9 here, this is already much better. Right? Then I can also do 24, that is even much better. Maybe I can swap all of that. It is 22 right now, 24. If I do this, then this is going to be 22 and 20, so going to be same. So I will probably not do it. Maybe I can try 10. Currently it's, I don't know. This way I'll be checking for everything. reverse. There should be something. I need to copy and should be 154 optimal. Can they also be optimal? Hmm. One comma 5 is also optimal swap. Thousand. Maybe I can do like reversing it is better. Hmm. How can I calculate the maximum change? Well, nums is only 10 to the power 5. So I can do dp if I really want to. I can use this. Going from negative to positive. N square is not allowed, right? Can consider first one and then we can do like next one. But okay, so can reverse from here as well. So in that case, only thing is going to change. Delta is going to be 5 minus 2 commod minus 5 minus 1 commod. So previous minus. So this one I can check like for if I'm reversing this, reversing this. Similarly, I can do for the suffix, but what about some middle part? I can't do n square, so can't check for everything. Do you know Samrat? Yeah, I know him. Yep. We are playing with differences. 2 4, we can pick IGS 2 4, then like 3 4 or 2 5. Guys, give me a minute. A 1 minute washroom break. can't hear anything. Hello? Okay. So like for these two cases, it's very simple. Let's say we have some array and we are breaking it into, let's say we have these four indices and we are breaking it from, no, we can also have anything in between these, right? Doesn't matter. We are breaking this part. Previously, it was a mod b plus mod of c minus d, right? Now it's going to be, these are going to flip. So a, d, b, c, right? I want to maximize this thing, right? How do I maximize it? It depends on the differences. So depends on the differences. Which one I can put? Do I need to find differences? What is the optimal? And this ABCD can be anything. I mean, there is a relation, they can only be adjacent to each other. We're maximizing this. Okay. So this should be minimum. So a minus b is minimum. So these were two closer points. So we have some points on the number line, and we were doing like difference between these two, and these two. And let's say they are some distance apart. These two and these two. After that, what I'm doing, I'm finding distance between this whole shit and this whole shit. How can I maximize this? This, if this is minimum and this is also minimum, then I can maximize them. No. If what will be the change? Maximize this. A and B is adjacent. Okay. Let's call this A plus 1. Call this TSC plus 1.
So what I do, I store minimum and maximum. So this is for minimum. I'll just equal to the first element. Then what I do, my loop will start from 1. Then my jth loop. What I'm storing is that minimum value to reach till there and maximum value. And if the current value is negative, I will try to multiply it by I need both of these, minimum and maximum. But like, if I have like both minimum and maximum, I will try to multiply it by both. I can go here, I can go right. Then I will multiply this value by both, whatever was minimum and maximum. Similarly in this case, and I will store like whatever is the maximum and whatever is the minimum of this operation. Then I will move to the next path. Okay, so now I have this first element. I need to move, but how will I check for rows? Because I'm going back. I can pre-compute. This is for the rows. Need to compute both minimum and maximum. This is 0th row. This is 8th column. N is the number of rows, so I'm going here. 0th column. So this is equals to what? Mini of I minus 1, 0 multiplied by rid of I comma 0, right? This is going to be minimum of, if I'm doing it anyway, this is the only way. So this is, I think, fine. Let's do it for the columns too. Less than M to 0I. Right now, I have multiple options. Mm, let's say so I am at some index. The value over here is going to be whatever is at ij multiplied by minimum of I j minus 1, right? Another one is going to be I minus 1, right? And these two are going to be with the maximum. J minus 1, I minus 1, and j. Now I have checked all the four combinations. Now many of this particular index, this is going to be minimum of all of these. Okay. Similarly, max is going to be max of all of these. So now my solution is going to be maxi of I n minus 1 and minus 1. If this is negative, okay, this is negative, then return -1. Else, we can return the same thing, right? We also have mod, and we have a overflow. We can perform mod, right? Why do I have overflow, by the way? Because of this. How can I deal with it? I-1 is already computed, right? Okay, missed it. We're getting some wrong answer. I need to perform mod. Okay, this is correct now. Good. So the logic was that I need to track both minimum and maximum, and I need to check all the combinations. Mhm. Because this can become maximum by two ways. If this is positive, then you multiply it by some maximum number. If this is negative, then you multiply it by some minimum number, which is negative. Yeah. Um, I'll do this. So can we don't use memoization? I mean, yeah, we can do that too. So we can see this only depends on the previous value. These two, right? We are not checking for any other value from. So we can definitely memoize. I mean, memoize, we can use like uh, two variables and solve this. This is a one state, this is second, this is third. So we need four variables. Using those four variables, we can do it. Is this like all maths? So A and B. Let's replace them. I want A minus D plus C minus B to be max. Plus C minus B to be max. What is their difference? A minus B plus C. That difference is, let's say, change. and this will be maximum. Okay, so we have something like this. Plus mod of C minus B, right? And we're subtracting and we want this to be max. Okay. Is there any property, because this A is similar, numbers are similar. I want this to be as smaller as possible. These both are going to be negative, okay? As smaller as possible. And these one to be as bigger as possible. E minus D is smaller. E minus B is bigger. When is this possible? Let's say if A is something like 2, B is something like 5, C is something like 2, D is something like 8. In this case, I have A minus B, C minus D, okay? When I will do A minus D, difference between these two. And I'm finding their so again, A minus B. So this is greater, this is fine. C minus B is this much. They are overlapping. And I want C minus D. C minus D is greater than, okay, this is bad. This is bad because C is less than B. So this is going to be greater. Hmm. 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 If these points are closer together, right, then A minus D, then we can get a good answer. A, B are close. But 2 घंटे हो गए. Given two sorted arrays, distinct integers, valid path is defined as follows. Choose array nums1 or nums2 to traverse. Hi, what's your name? Chaudhariya Bhai. Hello, bro. Arrays are sorted. Valid path is defined as follows. Choose array nums1 or nums2 to traverse from index 0 Traverse the current array from left to right. If you are reading any value that is present in nums1 and nums2, you are allowed to change your path. My voice is too deep, so I think it's a good thing. Thank you. Okay. You are allowed to change. Only one repeated value is considered in the valid path. Which college? MAIT. Mate. Change your path to the other array. Only one repeated value is considered in a valid path. Only one repeated value. So if 4 comes twice, wait, all values are distinct. Fine. Strictly increasing. This is also given. Sum of unique values in a valid path. So it is like, so once you matched with this one, you're not going to match like with anything that is coming previously. So you can go there, and whenever you see a match, you can perform this operation. You can start picking from the next element. So I need a state that which particular array my path is on right now. Constraints are tight. 10 to the power 7. Okay. No. Hmm.
You are allowed. That necessary. Will not.
How can I greatly do this? I want this sum to be maximum. I can go back.
Okay, so we have
this A and B, and then we have let's say some gap, and then C and D.
so currently it's like
A minus B, C minus D,
the distance, and now it's going to be A minus C, B minus D.
so
So it was before, now it's just
see,
so BD consists of the C and D. So we are subtracting it similar to this. So what is the change? Change is just the distance and like twice of the distance. And these if these points are overlapping, then this is going to be negative. We don't want that. So we want to pick some values of A and B
and C and D, like two pairs we need.
so gap between them doesn't even matter now. The
only thing matters is the distance, right? 2 into distance between max of AB minus min of C comma D. Right? Maximum minus minimum. Okay. Can I check this? Mm, A and B are consecutive. I can see what is A and B. Consecutive numbers. I can see what is. So in this case, what we have 2, then we have 4, then we have something like this. So what is the minimum? Maximum 4. Minimum is 1. So replacing this is good. And replacing this is good too. And how much change? The change is 4 minus 1, 3. Excuse me, what? Distance is not 2 times. Maximum minus minimum. But B and C should not overlap. Manan. uh, आजा सिखा दूं तुझे. Okay. C should be greater than equals to B. These are two endpoints. For example, 5 is greater than 3. 5 is also greater than 1. So this was it before, now it is going to be 2 times of what is 5 minus 3 is 2. 2 to the 4. Hell no. Fuck. I thought I'm so close, but I'm not. Damn it. Maybe I can start checking like delta for prefix, and also for suffix. So this can help. Not with one, so prefix it's going to be maximum of whatever it is right now. And what is the value after changing? So if I'm at over here, if I've decided to is 5, then original value is -1 mod, but now it's going to be 2. So this is just nums of I minus nums of 0. The absolute value of this this is the new value. So original value is nums of I minus nums of I minus 1. This is my maximum prefix delta. Let's go maximum suffix delta. Start with n minus 2. So what is the original value? Let's say I'm reversing this whole. This was the original value. And now it will become whatever. Okay, we have both max. Now I need mid max. Mid maxing. Think about mid. Let's check something out. coming out to be 1. What is minimum and maximum in both of these? Here, I was thinking about this whole thing, the last two. So let's see, between these two, this is a minimum value, 5 is the maximum value. So what do I do? Find their max and minimum and their distance. Track the maximum. This A minus B. The fuck? I'm at. So how do I get distance? I need maximum minus minimum. Maximum of what? Maximum of minima. This should be minimum of maximum. I want C to be as big as possible. But why this is not fitting in this case? What do I have? 2 comma 3. So 3 is maximum. Fuck it. What is like the maximum and minimum points? Let's say between 2 and 3. Maximum is 3, right? We can make a pair. Is minimum. Minimum is 2. I want maximum to be lesser. So between 2 and 3. What is C? So I did this like A and B, let's say. A is minimum of max. So this is going to be minimum of whatever the value is, and what is the maximum of out of these two. So this is 2 and 3. Let's say we have two things. So I'm tracking both. Say this is going to be max. how to maximize the formula. Yeah, I think this is similar logic. Okay, now let's check for pairs. Right, so let's say this is nums of I. So I'm going for like two of these. Now, what is mini? Mini is going to be minimum of mini, comma, maximum of these two values, right? So this mini, I need this C, and C has to be minimum. What? Yeah, C has to be minimum here, but it should be maximum. Do it for maxi. This is nothing but max of min out of these two. Now, is it long integer? Let's call it delta, initializing it as 0. It is max of delta, and 2 times maxi minus mini. Okay, so this is twice the distance. Now what I'm gonna return, so I also need this thing, and let's call it original. We can do it here. So original was absolute of v1 minus v2. Right. We will just return this original plus whatever is maximum out of these three. So it can be prefix, it can be suffix, it can be, could be delta too. Okay. Okay. Hmm. Is this correct here? So maximum is actually 5 here. Minimum is what is maximum? Here maximum is 3. Minimum is 2. Fine. Minimum is 1. $64. Answer is 8. So this is original number. No, this is the one that is changed. I'm missing something. 64.
Prefix and suffix. I'm starting from here.
And original is whatever is this one. If I'll reverse it, then I'm going to have and -1. That please seems correct to me, by the way. सिखा दो कैसे सिखा दो यार. I'm explaining while doing it. If you have any questions, you can ask. Is there any mistake in this prefix case? So I'm checking with I-1, and then I'm checking with 0. Is minus nums of 0. Both are same. Hmm. Well, seems correct to me. Current is this. If I change it, then 4 will become. Let me try. Okay, now it's correct. But this problem is so diabolical. How will someone figure this out? It's some maximum minus minimum, and this maximum is some maximum is like some minimum pair. Like some minimum between A and B. Hmm.
Because I'm pausing for a bit. I need like 5 minutes. Um, why is she calling me? I don't think I can solve this problem by myself because I can write this thing, but then A DAP. Hmm. I need to see this. Right, like I want this B to be as minimum as possible, and this B is maximum of some pair A and B. And similar goes to C. C is maximum, but it is like a minimum of the possible pair. And the distance. Hell no. This might be the last problem for today. So you can start from anyone, either nums 1 or nums 2, and we may change the path. Wait, my mic is working, but audio is not. Properties. Hello. अच्छा, वॉल्यूम कम है. ओके, अभी ठीक है. How do I do this? So I know this is a greedy problem. So 2, 4 then. These two are common, and there are some number in between. Seriously, it seems like ASMR. Like cozy vibes. Da, 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 da. Mm-hmm. So maybe the maximum possibility is sum of both of these, nums1 and nums2. Maybe I can do like this zigzag. Then I can try. Then I can try to remove some of them. Traverse the array from left to right. Right path.
So I can't go back. So the maximum possible is sum of all nums, right? That is like the upper bound, easy to think. Now maybe sum of maximum of sums, right? So that is like a lower bound. Now I will try to increase this lower bound as much as I can. But how? Let's say we have 4 here. I will look at the index where 4 is present here. I will try to take all of that. I will try to see whether this is maximum, this is maximum. Here my answer is going to be this is 9, this is 8, this is 6, and we also have 4 in there. This is definitely greater. So I will pick this path. Then we have 6. We don't have 6 here. Plus we have 8. We have 8 here. What we do? We pick this path or this path. So it's all about prefix sum. Okay. And then we can decide whether we want to pick this hole or this hole. So what do I need? I need 2 maps. Okay, one for this array, one for that array. Let's quickly. Both have a different size, I believe. So let's go in map on. So it stores index for some particular value. Okay, this is a value, this is a index. Done. Now we know that. Now we will try to. So this is our answer. Okay, we have to build prefix as well. So let's build a prefix. Prefix of size n and prefix of size m. We don't need prefix, we need suffix. Calm music and your voice. Oh my god, really? I just need a suffix sum. Okay. Now what I can do, suffix of n minus 1 equals to nums of 1 of n minus 1. Still similar to nums 2. I can traverse. Right, so suffix of 1 of I is basically suffix of, and they have said also that it could be large, so I should also do mod. Okay, I'll do it. Plus nums of 1 of I. That's it. Okay, this was for suffix 1. Now I'm doing it for suffix 2. Starts from m-2, goes all the way in. We have everything that we need. Now let's start. But start where? I can start with like the first map. So no. But doing it for this one is going to flip. After you have done the prefix, after you know that here you have to move, then what? Maybe I think my greedy idea is good. Okay. Now I need to look at I need to look for a good implementation. N and M is going to flip. Do I fix that? And I can't also go back. Maybe I can take 2 indices, I and J. I can start with nums1. How do I do that? Let's pick answer as maximum of suffix sum of them. Now we have this whole suffix sum and this one too. Now what do we do? If there is some index that is common, I can look at the suffix, whether suffix of this is greater or whether suffix of this is greater. Whoever has a greater suffix, I can move. (18.5) is 23. 17 plus 6. It's the same thing. Okay. It's the same thing, but I'm getting 4 extra. So if I'll switch a side, I will get this extra, like. Okay. What do I implement? Can maybe take minimum. Okay, this is a better approach. Let's take answer as 0. And let's say B, this is going to be minimum of n, comma n. I will go till here, then I will check how many indices are left. Will I check Very depressing. I can change this bound. So currently it's N. Okay. Maybe I can change this bound. Like if I'm changing the side, I can just change the bound. Okay. So if, how do I check? Oh, how do I implement this? Take 2 pointers, maybe. Hmm. Sum is greater. You move there. No 6, but there is a 8. I should probably not try to traverse this array. I can traverse the maps. That's a good idea. They're strictly increasing too. So there is going to be no overlap. If I'm moving to some other array, I will subtract the suffix next suffix and I will add the suffix of the next array. Okay. So both are at 0, 0. This is not hard. This is an easy problem. Solution should be somewhere. If I'm starting from here, will I always switch? Pin 3500. So 135. 135 500. Okay. No, it's not important to always switch. You are allowed to change your path. If one repeated value is considered. One repeated value? There are two repeated values. Two, 4, 5, 8, 10. Okay, they have also given examples. 2, 4, 6, 8, 10. I have to do this. Let's go with this thing, okay? So if map of 2, what is the current value? So if this is not in the second terms, then I just have to add it to my answer and continue. Nothing much, but here I have to do things. I have to check. Okay. So in, let's say this is suffix 1. This is going to be the suffix of 1 of I plus 1. It is only valid if it's fucking... it's not equal to n minus 1. Okay. And S2 is how will I manage these indices? I'm not doing this. Fuck this shit. 2-pointer solution. Seriously. We must take the common elements. But why? Could be a worse situation. And there will be two paths between the common elements. We will take and only take one path. We must take the common element and won't miss them. There will be two paths between the common elements. Yeah, there is two paths. We will take and only take one path. We calculate sum of both paths and take the bigger one. No. So from 2 to 4, what is valid? 4 exists. So whatever before 4. Four and 8 are common. Seriously? This is the solution. Oh my god. Maximum of the sums at each intersection point. This is max. Value reach till here. What is max? There are two intersection points. Maximum sum in between equal elements. Max of both. This I understand. Okay, if the value are same, we would calculate the sum of the array. If the value are same, Topological sort. Oh my god, this is good solution. Arrays are strictly increases, no duplicates. We can create a DAG where every node is a number. Oh my god, I could have thought. Okay, a good solution actually. There are no duplicates within each array, so we can create a DAG. Node is a number. We can do topological sort on a graph that tracks the path of the greatest sum. So what about in degree? So if these are common, then there could be a node between them. You can go in any direction. You can choose this direction. Topological sort is actually a pretty good idea. Wait, what? How do you? If in degree is 1, then you are appending, and you are taking nums of one of this value, and you are appending the next number. So you're connecting this, and then you're increasing the in degree of 1. It's same with nums too. And then how are you connecting these two? Because you can go from this 4 to this 4. So to go to this 5, we have this way and then this way. Okay. So 4 is connected. That means this 4 is also connected, and this 4 is also connected to 6. Distance equals to num. Go from 2 to 4, and then you can go from 4 to 6. But how do you you need 18 plus 6, 28, 30. Oh, so I only have to consider it once. I don't even read the question properly. This is why we can use topological sort. Makes sense. This is a brilliant solution. I love that. Pick one path and start traversing. You will either go on path 1 or path 2. Also store all values and index of both paths in a map to access later. Possible. Maximum sum of 2 sorted arrays. For elements unique to each array, if current element of both arrays are equal, add the maximum of sum 1 and sum 2 plus the common element to the result. Reset both sums. Remaining elements after traversal, add the remaining sums. So what I'm trying to do, I'll start from here. Because this is smaller, I will move here. This is greater, so I'll store this in a sum and I'll make it 0 and then I'll move to the next one. I didn't even see this. I've solved it like sleep. Okay. We also need to track, let's call it A and let's call it B. Okay, let's go. Let's use a while loop. But I is less than n. Okay. So we have to check. Okay, so while I can just use a if condition here. So if nums of 1 of I okay, so nums of 2 is greater. So what I do nums of 1, I sum this, I'll add the sum and I'll move to the next index. Okay, else if what if both are equal? Both are equal. Okay, so fix this J. So here nums of I is greater. Say this is greater, so I should just sum up J and move nums 2 of J and move this J. Okay. Now, if both are equal, then I have to see if A is greater than B or equals to B. When we have the same number. Let's take answer as 0. And I'll make A as 0 and I'll do I++ because I have decided to pick this thing. Okay. Add this thing up. I'll move here. So A is going to be 5 and B is going to be 4. And then you move to 6. You see this is smaller. So you move to 8. Then you take both of these two. Because this is equal, you pick this one. Else answer plus equals to B equals to 0. And let's do J++. I think all the conditions are done. Now maybe something is left afterwards to the while loop. I need to add all those remaining paths. So if I is less than n, and can return answer. Are there mistakes? For now, I can do this. Okay. We got TLE. We are going like okay. Wrong answer. We got 22.
So we see J is greater, definitely.
So you just did this 2 and you move to this index. Now here both are equal.
And goes to 2.
Goes here, then you see A is greater, so you add 2 to the answer. You move this I. You have not added 4. So if both are same, then you move both of them. Okay. And you make both of them 0. Right. And you also add whatever is. So A is greater means nums of I. Fine. Both are same though. Here you add a B. Okay, now it's good. I'm moving both of the pointers because numbers here are equal. But if A is greater than equals to, then just add this fucking A, right? Else add this B and reset everything. So For now, this looks correct to me. If I is greater, mm, also is it 1e9 plus 7? Yeah.
Ten to the power 7 plus into 5. It's 10 to the power 12. So we are safe already. Okay.
We can see something. When j is greater, else you add up whatever is greater, I plus plus j plus plus, and you make both of them 0. This is exactly what I did at the remaining maximum of the remaining sums. What? Oh my god, this is also possible. I did not see it. Right, so maybe I have something here too, so I need to add. Wow. What the hell? B plus nums 2 of j, because B is greater, and I'm making both zeros, so ओ भाई 3 बजने वाले हैं, कॉलेज में फेस्ट है, मैं निकलता हूँ। guys. See ya tomorrow.